Good morning, everyone. So I'm just trying to figure out if I can make it better lit on me for the purposes of this class, but I may just need a better lighting source. All right. Today is March 27th, 2023, and one of the things that I wanted to do was if I remember correctly, last week this is where we kind of ended. Where we got to the last couple of slides about defining the problem, and if you go back and look at some of the let's see which this one, the Charles Kettering quote here, the problem well stated is a problem half solved, and just really understanding what how to define our problem, how to define what it is we are trying to research is very important. And so kind of wanted to make sure that we didn't just gloss over this, but make sure that we really kind of talk through it. Okay, so some of the key points is we need to make sure that the terms are clearly defined. Like, what is it that what if there, especially if there's any potentially ambiguous terms, or if there's any terms that might not be well known outside of a very particular group of people. So, you know, if we're writing, say we're writing a paper that's intended to be submitted to a science and technology journal, but we want to make sure that terms that are specific to whatever we are particularly researching, say it be model-driven engineering, which is one of my focuses, or artificial intelligence, or machine learning, or anything like that. Those, if there's terms or things that are very particular to that field, we want to make sure we have a clear understanding of what they mean, right? Clearly stated assumptions. If we're going to make an assumption to say, okay, we assume this thing to be true, or we assume this thing to be false, we want to make sure that is covered as part of the problem, statement. You know, why are we doing this? Why are we studying this? What purpose, what value does it have? Is it something related to making the world a better place? Is it something that will help us understand something about the universe better? We want to understand that we have looked into current sources, that we are not just what is it I was trying to say, that we're not saying, oh, this is a problem that exists and we want to look into it, but we want to make sure that we've looked into what's already been looked at and what's already been done. Okay, and the scope, clearly defining the scope, making sure that we are setting boundaries that are setting boundaries around what it is that we are researching. Okay, so let's look at a couple of bad examples that I have up, that I had shown up right last week, and let's talk through, okay, what makes these bad examples? What are some things that or do you agree that these are bad examples? Maybe I should ask that first.
Are there no Americans that are healthier than some Turks, right? Not all Americans are as healthy than.
Okay. Yeah. Okay. Yeah. So I guess what you're kind of getting at is
too general.
Yeah. Yeah. What? Go ahead.
What I'm trying to get is that the first question is way too general, and that it doesn't actually involve, or rather take into consideration every single member of those two groups. So that statement by itself is not always true, right?
Mm-hmm.
The second one kind of is ambiguous, whether it's true or not. It's just, I have no idea. For example, a guy like me can't, off the top of his head, say that, yeah, there is some truth to that. For the second one, I don't know, there's quite a few problems with both of those, I guess.
Mm-hmm. All right. Okay. So yeah. So I forgot that when I put that second one up there, that one is actually a holdover from 2 years ago when I taught this course, and one of the students in that course was one of my graduate students that I was advising, who had his undergraduate degree was in physics. So that's kind of was a joke on him. Yeah. Right. So you so
the inside joke.
Was that now?
I'm sorry we didn't get the inside joke. It was
Well, no, you guys don't know him, so you may not. Well, I mean, I don't know if you know Seth or not, but he's in our doctoral program now. But yeah, so that was an inside joke there. So you wouldn't have necessarily understood that, but the class that year knew him, and so knew that was a joke there. But yeah, so Shadin says bad because they give a final judgment from the beginning. So maybe what you're saying is we're kind of, in a sense, we're stating an assumption, right? Both of them are stating an assumption that's true that may or may not be founded, right? Like, what is that? So let me ask this question. What does it mean? What do we mean by healthy, right? How do we, well, if we're going to say the assumption is that Americans, and Urjan, you brought up like not every member of that group, right? Yeah. So one of the things that would make it more specific or more scientific in its statement would be to say, why are Americans in general less healthy than Turks in general, right? Or why is it that generally Americans are less healthy than Turks? And then that would at least be saying our problem is not why are all Americans less healthy than all Turks, right? It would be saying specifically there's some generalization going on, right? But even that question is like, okay, what does it mean healthy, right? Like, would you agree? I mean, would you guys? And you're not going to hurt my feelings if you say yes or no to this question, but would you agree that Americans are less healthy than Turks?
Is mental health considered regular health? Does it fall into that umbrella? Because if so, I think most Americans are healthier than most Turks, right?
Yeah, so there you go. So that's the kind of point is, what does it mean by healthy, right? And when I wrote that question, like one of the things that was coming to mind was actually there was a friend of mine that lived in America. She was not from Turkey, but she was from somewhere over in this part of the world. I just can't remember which country. But she was asking a friend of ours over there, like, why are Americans so concerned with, exercising, and people in my country, we don't exercise, and why are they concerned with this or that? And like basically what they realized was that in her country they ate a lot of fresh fruits and vegetables, which Americans in general don't do, and Americans tend to generally drive many places that people in other nations would walk. And like I can even remember joking with a friend of mine once, it's in America you will drive like 2 blocks to go to the gym, to go to the fitness center. Then you will try to find the closest parking space to the building so that you can walk as little as possible to the building. And then once you get in the building, you will get on a treadmill and walk nowhere. And so the point was that what my American friend was telling this girl was, in your country, you eat more fresh fruits and vegetables than we have in America, because a lot of American food in general is processed, and you walk more than Americans, so you get natural exercise. And so for this reason, a lot of people in your country are healthier physically than Americans. And so this is where that question came from, right? But as Urjan, as you pointed out, mental health, I believe that mental health would be part of of overall health. And so if you think that Americans are healthier than Turks in at least as mental health is concerned, then that's an assumption you wouldn't even agree with. So we have to at least identify what does healthy mean, right? So let's see. The question is, why are the average Americans people? Yeah. So, Barak, I think if we would at least define what does less healthy mean, then let's say, for example, my experience, and I have no data to back this up, so don't cite me, right? Don't cite me on a paper if you do this. But my experience is that Americans tend to, on average, have higher obesity rates than the Turkish population, right? And so I would say that Americans have a worse problem with obesity than Turks, right? Again, that's my experience. I don't have data to back that up. I'm sure there's a study out there that we could find that would talk about that. That would talk about obesity rates across different countries and different regions of the world, right? But at least if that were true, let's assume that is a true statement, that on average, no matter what, you're going to find, if we say, okay, the study is, we're trying to discover the causes for why, in general, the American population has a higher obesity rate than the Turkish population. Okay? That could be, we're getting closer to a good problem statement. Okay. Does that mean that every American is more obese than every Turk? Like, no, of course not. There would be some American out there that would be less obese, that would be less overweight than, and even underweight, honestly, than some Turk that's probably overweight, right? When we get into these things, we can't be looking for one of the things that we start getting into analyzing results and conclusions and stuff like that too, is we're not looking for 100%, right? So even like in vaccine trials, like during the pandemic, you weren't looking for a vaccine that, you weren't looking for something that prevented illness, prevented the virus transmission, or prevented bad cases of the virus or death. You weren't looking for that 100% of the time, right? They were looking for numbers like 80%, right, or something like that, because what they're saying is like everybody's body is made differently, right? So you can't look for something that is a true 100% of the time, because otherwise we would never have, you know, any successful research being done, right? You're looking for what's the word? It's called statistical. Statistically significant correlation. Okay, so you know, it's one of those things where if I had a coin, if I pulled out a coin, all right, and I said I'm going to flip this coin 100 times, okay, and out of those 100 times, 80 times it comes up heads, you would probably think there's something not normal about that coin, right? You would not think that just randomly the coin managed to come up heads 80 times and tails 20. Like, you wouldn't think that a normal coin would do that, right? Now, if it were to come up heads 55 times and tails 45 times, you'd say, that's not really statistically significant. Like that's a normal coin, right? But if you were to see it come up like heads 80, 90 times, or even sometimes maybe even 75 times even, you would say that's not a normal coin, right? So you're not looking for 100% of all people individually, right? But that is a good question, because that is one of those things that oftentimes where research can have a difficult time being accepted by the general public, because people will say things like, oh, well, yeah, my friend had this experience. Like, so for example, I had friends that during the pandemic, they would say they would not accept the vaccine because they had a friend who had a very negative reaction to the vaccine, and maybe even got very ill and went to the hospital. Or they would say, my friend got the vaccine and they still got COVID anyway, and so therefore to them they're like, the vaccine does nothing. It's pointless. Are there going to be some people individually that, and not just COVID, but any illness, are there going to be some people that will have a negative reaction to the vaccine and it won't help them? It won't help them, prevent them from getting the illness? Absolutely. That's going to happen. Because one person, or because some small population of people do have these negative reactions or non-reaction to the vaccine, they don't get helped by it, does that mean that we should just throw out the vaccine and not use it? I would say no to that also. Like that should not be our reaction. Just because it doesn't help every single person, therefore we shouldn't use it. Does that make sense? And is that along the lines of what your question was there, Burdock? I want to make sure I covered the question you were asking. Okay. And I would say even like the other one, the computer programmers, better employees than physicists, even that kind of suffers from some of that same, what does it mean to be a better employee? Like, what metric are we using, right? Are we talking about working hours? That computer programmers work more hours? And even that doesn't necessarily mean that someone's a better employee just because they're working more hours, right? Is it that, you know, what is it like? There's some metric we need to, if we're going to ask, you know, why is this group better or worse or less or more this than another? We need to define what those terms are, right? Okay, so I was trying to think of another bad example. Well, and like even like a simple, like we talked about before once, is, you know, how can we make the we wanted to research how can we make the world a better place? Well, what is that? Like there's a lot of ambiguity, a lot of terms that are not. And we talked about that before. And Burdock, I believe you were the one that brought up, like, are we just talking about making the world a better place for humankind, right? Because even that would be an assumption or a term that would need to be defined, right? What is it that we mean when we say better, making the world? What does it mean by world, right? Right. So maybe if I maybe during the week I can come up with some other bad examples, and we can kind of maybe I can post those on the chat and talk through how we can make them better. All right. Okay. So the reason why I wanted to go through this again was I wanted to make sure that let's see, right, that we are making sure that we are clearly defining the terms, the assumptions, why, what are we doing, like, and even like, because some of those things are not done here, right? Even some of these, why, what is the value? What is the value in learning about why Americans are less healthy than Turks, if they are? What is the value in learning why computer programmers are better employees than physicists, if they are, right? You know, what do we hope to gain from this, right? Current sources, okay, obviously I don't have anything in that, right? And scope clearly defined, right? I would say one problem though, one thing that we also do need to make sure that we are being able to communicate is we need to be able to communicate concisely as well. So the problem statement is not the paper, right? The problem statement is what is it that we are trying to research? And so we want to keep it short, right? We want to keep it, and when I say short, I don't mean like 1 or 2 sentences, right? In fact, when I first start overseeing the work of a student, whether it be a graduate student or a senior design project, the very first thing I encourage them, I get them to do as I start considering the project or the thesis is, what is the problem statement? And I need you to write a problem statement that needs to be at least a full page of text, right? It needs to be clearly defined because it needs to include a few sources. I want to make sure that you've done some preliminary literature review stuff to find out what's out there. It needs to be long enough that it covers a lot of these bullet points that we have listed here, right? But it doesn't need to be so long that it tries to get into things like methodology and it doesn't need to be a related work section. It needs to be it needs to clearly define what is it and why is it that you're writing, that you're researching what you're going to be researching. Okay. All right. Let's see. So if there's not any questions more about that, what we'll do is we will move on to the design. Okay. All right. So once we've determined the problem, and there was one comment, was comparison as bad as they're generally too problem. Yeah, I could agree with that. I think comparing 2 or more things, but you need to be specific in what you're comparing them in. So like even for example, that first statement about Americans and Turks, there's going to be some health category that we could say there may be data that suggests that group A is healthier than group B in some health category. You're also going to be able to find some health category where group B is healthier than group A, right? There's never this like, I would think it's very rare to find one group being completely healthier in all measured health categories, all quantifiable health categories, one group being healthier than the other in all of them. I think that would be, if someone can find that, I will take back what I just said, but I can't imagine it being found. So I'm not saying it doesn't exist, but maybe that can be a research for one of you guys. So anyway, but yeah, I think you're right. I think most comparison statements are bad because they're generally too broad. Yes, I agree. All right. All right, so once we have defined the problem, figured out what it is that we're going to be studying, right, we need to begin a literature review. Okay. Now, again, hopefully you've already done some preliminary literature review as part of developing the problem statement in the first place, right? And so hopefully you've looked at some of the current work that's already been done. But once you've developed the problem, you need to start kind of compiling a list of sources, right? Now, this is going to be, the literature review will be the backbone, the preliminary literature review is going to be the backbone of your references section of the thesis or the paper that you end up writing. Okay, so one of the points of why you need to have an extensive literature review is you need to show that you understand the topic, right? That you've done enough work to understand what's already been done in the area that you are writing in. Okay. Now this is going to include both the large topic, the large subject area, as well as specifics about what you are trying to do. Okay. So for example, my own student Seth that I mentioned earlier, who worked on a recommender systems for journal publication, right? So his thesis had to do with using an artificial intelligence algorithm to be able to train it, to be able to have it use the abstract of a paper that an author had written to determine what the best journal, best being a comparative word, I got it, but to suggest a journal for them to submit to. Okay, now, so recommender systems is part of his literature survey, literature review. Artificial intelligence, part of his literature review. Other work being done specifically in the area of well, not recommender systems, but I can't think of it. The picking the right journal. I can't think of what that was called. What specifically the field was for that right now. But there are other existing tools for the purpose of recommending which journal or conference you should publish a paper to. Okay, so some of that already exists. So his literature review would be both the broad and the very broad topic of computer programming and computer engineering, generally as well. So you're going to have literature from different levels of your field. Okay, so you're not just looking specifically for stuff related to the very particular topic you're studying. You're also wanting literature related to the broad topic as well. All right. Now, once you complete your literature survey, and don't think, let me pause for a second and say, don't think that once you've gotten your sources, you've got your problem statement defined, you work on your hypothesis, and you say, okay, I got this hypothesis, and now I'm gonna start working on the experiment or the developing the solution, or whatever it is whatever the nature of your research is, right? Don't think that you're done doing looking for papers and articles at that point, because new stuff will come out while you're working, right? And you do need to keep up to date with the new stuff that's going to be published while you are working on your experiment or whatever it is. Okay, right? And so, but once you've done a literature survey, but at the same time, don't think that you need to have every paper that's ever been written related to the topic that you're studying. Okay. At this point, we are at a place now where that would be quite impossible to be able to read and completely digest and understand every paper that's ever been written on a topic and be able to include it as part of a literature review, because there's just way too much information that is available now. All right, but so you create the hypothesis. Once you have your hypothesis, you start preparing the design. Okay, so how am I going to test the hypothesis? How am I going to design the experiments for the purposes of testing my hypothesis? one of the important parts of why I wanted to make sure to cover the design aspect, is we don't want to just, once we've done the literature review and created the hypothesis, we don't want to get to this point and say, okay, let's just figure it out as we go along, right? There's a saying, I think it's probably been stated by a lot of people, but I know Winston Churchill said something along the lines of, he who fails to plan is planning to fail, right? And so we need to come up with a design, a plan for how we're going to test our hypothesis and how we're going to obtain the data that we are trying to obtain. All right. So again, we can group into 4 categories. What type of research we are trying to accomplish. We're going to explore to learn more about how things work. We're going to try to describe in detail something, a system or something that in that way. We're going to try to diagnose the problem of what is the cause of the problem that we are trying to understand, or we're going to run an experiment. And most of you probably, I don't know, when you think of experiment, I don't know, do you think about, having a single control and then a couple of variables and seeing how the control group works in comparison to the variable group? And that is definitely one way that an experiment can be performed, but it is not the only way. Right? So in fact, there's a lot of different ways that experiments can be done, right? We can have things like informal designs, right? So you can have before and after without control. Okay, so there's we don't have a control group. We just see what happens when we apply whatever it is that we're studying, when we apply it to the organism or the group or the system or whatever it is, and see what happens before and see what happens after. Okay. We can have after only with control. We're not necessarily testing what the situation was before. Right? We can have before and after with control. So we can have control groups and we can have without control as well. Right? As far as formal designs, we can have a randomized design, right? So different like randomized block design, Latin squares, simple and complex factorial designs. These are probably, we won't look into those specifics. We won't look into them in much detail in this course, but it is something to understand about the different ways of creating the, changing the variables, right, and changing the values of the variables to understand the differences there, okay? Basically, yeah, that has to do with when we change a variable value, how do we do it, right? And where are some of the endpoints? Because say, for example, something as simple as making coffee. I just thought of making coffee because my brother-in-law was showing me on FaceTime the other day about, he has like one of those scales that he measures out like 22.5 grams of coffee or something like that, something like something 0.5 grams of coffee, and then he puts in like 237 milliliters of water, like, and this is like, he's very, very fine, right? So and the point I'm trying to get to is, well, what would be different if you did 238 milliliters of water or 239? And should we test those out to that level, right? And as you can imagine, even just testing every 0.1 gram of coffee between, let's say, one whole number and another whole number, like so 22 to 23, and every 0.1 gram within that, along with every 1 milliliter of water between two tens, so 220 milliliters of water up to 230, that alone would be 100 different types of coffee, right? 100 different ways of making coffee, right? Which can cause a lot of time, especially considering probably a lot of those within that range are going to be very similar to each other, right? So coming up with smart ways of being able to test these things out, of how to change the variables, right, and how to set the variable values, the independent variable values. Yeah, especially in coffee, right, Uberjohn? I don't know if you guys are coffee drinkers or not, but my brother-in-law, it's interesting. He's one of those coffee connoisseur people. So anyway, let me get to. Let's do mention about the dependent and independent variables, right? So concepts like weight, height, income are examples of variables, right? There can be also qualitative, right? Could be on the basis of the attribute, the presence or absence of an attribute. We can have continuous. We can also have discrete variables. In fact, in modeling and in simulation modeling, there's different types of modeling systems. MATLAB puts out one called Simulink that is a discrete type of system that uses discrete values. Let me see, mostly discrete. And then Repast is another one. It's an agent-based modeling paradigm that can use more continuous variables, but discrete simply means that there are jumps in values. There's not like it's not a continuous line or a continuous curve, right? And so we could test a discrete value might be something like an integer variable could be a discrete variable, right? So you can't test 1.5 of something, the variable being set to a value of 1.5 for a discrete variable, perhaps. All right. The problem is that sometimes, and especially in computer systems, it's difficult to test something that in reality is continuous because the computer system has to give it a very specific value. So for example, even like in this example down here where we talk about height, right? The height, we would probably think of that as a continuous variable, right? My height is continuous, right? It's constantly, well, it was going up. Now, as you get older, it starts going down, but it was continuously going up, right? But it was not like, at one point I was 183 centimeters. At another point I was, I am 183 now. At one point I was 100 centimeters, right? And then at another point in time I was 101 centimeters. Now, the time from 100 centimeters to 101, my body went through all of the values between 100 and 101, right? But those were not measured, right? And so in computer systems, because variables are stored in integer values and in double values, and they're represented using floating point notation and bits, basically. There are limitations to what we can represent for the values, but for the most part, I would say it isn't a big problem, right? All right. So as far as variables are concerned, we can talk about dependent and independent variables. We might say that height depends upon age, right? Then we would say that height is the dependent variable and age is an independent variable, right? And even an age is itself, it's a kind of, is that a continuous or discrete variable, right? Right, because my age is constantly changing very, very little bit, right? But anyway, so we could say that in this example, height would be the dependent variable. So age is the thing that's changing on its own. Height is the thing that is dependent upon the age. Right? Obviously, different people are different heights at the same age, right? Some people are the same age as someone else and taller, right? So we can't say that that's a great example, but it is an example of how you might say that someone's what is a dependent and what is an independent variable. Now we're running out of time, and I did not get to. Let's at least mention control groups. I want to at least mention control groups before we pause for our break time. So you've probably heard, you may have heard what a control group is in experimentation before, but basically the control group is a group that is not exposed to whatever it is that we are testing. Okay, so they are what we call exposed to usual conditions. Right, so they in a medicine like a chemical medicine or vaccine type experiment, they would be exposed to something that is not the vaccine, that's something that will not or should not affect their bodies. And then the experimental group is the one that is given whatever it is that we are trying to test for, to see how it affects whatever it is that we are studying, right? And there are things that there's the term placebo that comes into play a lot of times in these types of studies as well, because sometimes the control group will have a positive reaction. So for example, a control group, maybe they're testing for a new drug for some type of cancer, right? And the control group it would be a group of people who have that type of cancer, but are not given the drug that we're testing, right? And then that some people in that group may have a positive reaction, meaning that their cancer reduces or something like that, or they go into remission or something like that, right? This, a lot of times they would call this the placebo effect. The belief that you are getting something that's helping you may actually cause you to be positively impacted, right? So that can come up in these things. So the question oftentimes is, people will ask, so how do we test for the placebo effect, right? So that would, if anyone can come up with a way to test for the placebo effect, that'd be great, right? But basically what you're doing in this situation, in an experimental, having an experimental group and a control group, is you're wanting to see, you're expecting that the control group will behave, their results will behave similar to if you had done nothing at all for them. That's what we expect to see from that group. The experimental group is, okay, we're going to compare at the end what happened with the experimental group, what happened with the control group, and if a statistically significant improvement was made with the experimental group, then we will consider that our hypothesis was a success, and that whatever it is that we're studying, medicine, some new safety feature on a car or something like that, is beneficial and should be considered. All right. Okay, so I went over a little bit on the 10-20 limit, but I did want to make sure to talk about control and experimental groups. Is there any comments about what we talked about here so far? Sadly, yeah, and that Barack, you bring up a great. That's probably an ethical question, honestly, and maybe one that we could include as part of our discussion one week. But yes, that in a sense they are just kind of unlucky at times. Well, let's say this: they're the unlucky guys if the drug turns out to work. They may be the lucky ones if the drug turns out to not work, or even maybe cause more problems. Because there have been times in some of these controlled studies where the experimental group not only was not helped significantly with whatever disease they were studying, but in fact they even also had adverse side effects. So on top of having continuing to have the disease, they also have bad side effects. So who's the unlucky ones in that situation, right? But the way that this type of experimentation is designed is we don't want you to know that you're getting a placebo, so that we can have a better assurance that what we are seeing is any differences between the experimental group and the control group, we can say with more certainty is due to the drug we're studying, or due to the solution we're studying. But yeah, Malasef. All right, so let's take a break there. Maybe if you were studying a new security feature against some type of cyber attack, you could have one computer system that does not get the software update and one computer system that does get the software update, and try to attack with both. Maybe something like that. But yeah, we probably don't do a ton of experimental and control experiments in software development, but we do use simulations and software to run these types of experiments. Right. So, but that's a good point. All right, so let's take a break. We'll come back in 10 minutes, and please, if you can, go ahead and pull up those links. I'll have it on the screen too, but go ahead and pull them up. The one on the new channel about links and articles and stuff, and we'll talk about the code of ethics for engineers. All right, see you guys in 10 minutes.